Have a look at this beautiful Chicago typewriter from the 20s. It survived 1 century without a scratch, and it only took the importer a few hours to ruin it. Welcome back to Backyard Ballistics. Today I'm taking apart and reviewing a Thompson 1928 submachine gun, which as you might expect was converted to semi-auto only. This is a common practice for military full autos, but this case is different. Like many submachine guns of the time, the Tommy gun used to shoot from an open bolt, meaning that the bolt is cocked back and stays open until the trigger is pulled. Once that is done, the spring pushes it forward, picking the first round from the magazine and striking its primer as soon as it is chambered. The open bolt firing is simpler, since it doesn't require a separate firing mechanism, and allows a straight blowback action to work safely and reliably with a lighter bolt group and weaker spring than what would be needed for firing from a closed bolt. Unfortunately, this system is also prone to accidents, since if the bolt is accidentally released before engaging the trigger, a shot is automatically and suddenly fired. This caused many accidents in the past, and is the reason why the open bolt firing in submachine guns has fallen out of favor, and you almost never see it nowadays. But the main problem for civilian gun owners is that open bolt firearms are intrinsically very easy to be converted to full auto, which is the reason why during the conversion to semi-auto, they also have to be converted to closed bolt firing. Now, I don't want to moan about that. They may be ruining some historical weapons, but it is for a good cause. The only thing I am complaining about is how badly the conversion was done in this particular case. As you can see, the original parts of the weapon are quite well preserved despite the age, even though I think the lower receiver has been refinished. And the barrel is in very good condition, something not so common for guns coming from the era of corrosive primers. What caused most of the harm for this piece is the work done by the importer to make it shoot from a closed bolt. Now keep in mind that this gun sells here for over 2,000 euros, so we're not really talking about cheap stuff. If you have ever disassembled an unmodified Thompson, you know that it doesn't look like this, and it was to be expected, since modifying the bolt group is what changes the firing from open to closed bolt. The problem here is how badly the conversion was carried out. Differently from other closed bolt conversions that I have seen, this importer decided to keep the original main bolt and modify it to fit some additional parts, mainly a very sketchy striker mass that engages the trigger sear and 2 additional recoil springs in parallel. So here I've just removed the springs. Consider that in the original gun there was only one main spring in the same position as to where the new striker spring is placed. Now you see me remove the striking mass. It is a very crude construction with a rough and seemingly hand-cut extension welded onto it that engages the trigger sear in the lower receiver. Of course, in order for this to work, they also had to slice open the bolt body, providing a channel for the striker tail to move back and forth. So let's take out what is left of the bolt. You can clearly see it has been heavily modified, but I'll get to it later. Then comes the Blish lock. Even this part had to be modified to make room for the striker, and since the machining would have left too little material for the part to be structurally sound, they sloppily reinforced it with what appears to be a screwed-on plate of aluminum. Also, the heads of the screws they used were too big, so they opted to grind away part of them to allow the lock to fit in its place, which doesn't look very professional at all. Now let's go back to the bolt itself. You can clearly see the long channel where the striker tail passes and how from there it reaches the back end of the firing pin, which could be the original one, hitting it and basically working as an internal hammer. But the striker channel is not the only cut they needed to do, unfortunately. They also had to provide another gap in the base plate of the bolt, this time for the trigger reset mechanism. This protrusion is what engages the gap when the bolt is closed and is pushed down when it recoils back, so to automatically reset the trigger at each shot and avoid the gun going full auto or jamming. This is the trigger sear, which holds back the striker until the trigger is pulled. At that point, a shot is fired and the bolt recoils backwards. In doing so, it pushes this protrusion down, causing the trigger to reset even though it is still being pulled. These 2 slots that have been cut are very detrimental to the structural soundness of the bolt itself. The left-hand part of the bolt body is attached to the rest of it in just 2 very narrow points. One in the front, which is so thin that it has already broken off, and one between the 2 slots, which is quite thin as well, and is the only remaining piece keeping the left-hand part attached to the rest. Then comes the Blish lock. As you can see, they had to machine a groove in it as well, so that the striker could reach the firing pin, and that's why they had to screw in some reinforcement to prevent it from falling apart. Now let's stop complaining and have a look at how this odd system worked, or actually didn't work. The idea of John Bell Blish, hence the name, was based on the assumption that the frictional behavior of different metals changed depending on the pressure that was forcing two parts one against the other. In particular, he expected the friction coefficient to increase significantly when a relatively large pressure existed between two sliding metal bodies. Unfortunately for him though, this was not the case, and the Blish lock was performing much more poorly than he expected, so that the following variants of the Thompson didn't include that lock at all, and even the ones that had the Blish lock in place were actually operating almost like a straight blowback would. Almost, but not quite. Even though the Blish system is nowadays totally discredited, since its working was mainly based on the wrong assumption of the increase of the friction coefficient, in reality even normal friction, which is definitely real, takes a part in this mechanism. In particular, in order to move backwards, the bolt needs to push the lock up, and because of the angle the faces of the Blish have relative to the bore axis, a substantial amount of friction is generated, which has to be overcome to let the lock disengage so that the bolt can move back. So we could name this a friction-delayed blowback, but in our anatomy the friction delay obtained is small, and that's why we say that the operation is almost that of a straight blowback. If we wanted to increase the delay, we would need to put the angles at a greater disadvantage, but this renders the outcome of the shot heavily dependent on the friction coefficient, which is modified by things like dirt and oil, causing unacceptable inconsistencies. I wanted to demonstrate this, but some math is involved, so if you're interested I may upload it separately. Anyway, in the upper receiver you can clearly see the grooves into which the Blish lock slides, and a felt buffer that acts as an end stop for the bolt to absorb excess blowback energy and reduce the firing rate a little. Also notice the grooves needed to attach a drum magazine, the barrel heatsink and the nice cuts muzzle brake, all of which will be removed in the later iterations of the design. Now, getting the three springs back is just as painful as it looks, but it gives a clear visualization of what happens when you want to shoot from a closed bolt a gun that was designed to fire from an open bolt. Since they couldn't increase the weight of the bolt significantly, they had to increase the overall spring stiffness, and if originally just one spring was needed for the open bolt design, now three are required to absorb the excess blowback energy. This also means that a much stronger force is required to move the handle manually, which will be quite annoying later. Anyway, once everything is back together, we can give a look at the iconic drum magazine this gun could be fitted with. Luckily I just appear to have one, but as you may see I am really struggling to attach it. The reason is once again the conversion from open bolt to closed bolt. To fit the drum magazine, the bolt needs to be cocked back, which is not that big of an issue for an open bolt firing design, since it would be held back by the trigger sear anyway. With the conversion to closed bolt, however, a manual hold open should have been introduced, something that the importer didn't bother to do, so you have to manually hold back the handle under spring tension while the drum is being fit. But remember that now we have about 3 times the spring tension, so this procedure is far from comfortable. But once this is done, we can finally relax and have 50 rounds to shoot without changing magazine, right? Well, no. Even though our current regulations allow for high capacity magazines, this one is old and was modified to only hold 10 rounds, which is half what the normal box magazine held, making the whole thing purely aesthetic. They basically ruined an historical, iconic and rarer than hen's teeth piece, but let's again hope it was for a good cause. Just look at how crudely they crippled it though. Anyway, let's load it. And by the way, this is not the same way you would load an unmodified one, which is also the reason why I won't cock the spring after loading it. And finally to the range we go. Now, the start wasn't really encouraging, and at first I thought I had messed up something during reassembly, but that wasn't the case. Apparently, during his brilliant job, the importer didn't design the springs correctly, so the striker hits the firing pin too weakly, and this results in very light primer strikes. To quickly sort this issue, I switched to Cellier and Bellow ammunition, which usually have softer primer caps, and they indeed worked fine. Well, most of the times. Anyway, I really hope you learned something new, and I'd love if you could tell me if you liked this video or not with the thumb up or down buttons. Subscribe if you'd like to see more, and for those of you who can and want to directly support the creation of content like this, you can find me on Patreon and see your name here. Thanks a lot to my very first patrons, Carson Polar and Leonardo Macella, and I'll see you next time. Bye.